Nobody told this software what a cat looks like, yet it can spot one in a photo. Here is exactly how that happens. A neural network is just a pile of numbers called weights. At the start of training, those numbers are basically random guesses. You feed the network a photo of a cat, and it spits out an answer. That first answer is almost certainly wrong, because the weights are still garbage. To measure how wrong it is, we use something called a loss function. Think of loss as a score, where 0 means perfect, and anything higher means the network needs to do better. Now picture a hilly landscape. The height of any point on that landscape is the loss. The network's job is to roll downhill until it finds the lowest valley it can reach. The process of rolling downhill is called gradient descent. A gradient is just a fancy word for slope. It tells you which direction is uphill and how steep it is. The network takes a small step in the opposite direction of the slope, because opposite of uphill is downhill. Then it checks its loss again and takes another small step. How big each step is depends on a setting called the learning rate. Too big, and the network bounces around and never settles. Too small, and training takes forever. But here is the tricky part. A neural network can have millions of weights. How do you figure out which direction is downhill for every single one of them at the same time? That is where backpropagation comes in. After the network makes a wrong prediction, the error signal travels backwards through every layer, all the way from the output back to the input. At each layer, backpropagation uses a rule from calculus called the chain rule to figure out exactly how much each weight contributed to the mistake. Once every weight knows its share of the blame, gradient descent nudges each one in the direction that reduces the loss. This whole cycle, forward pass, measure error, backward pass, adjust weights, repeats thousands or millions of times. As training goes on, you can watch the loss curve drop. It starts high and jagged, then gradually flattens out near the bottom as the network gets better and better. Nobody wrote a rule that says a cat has pointy ears. The network figured that out on its own, just by adjusting millions of numbers until the loss got low enough. That is the whole story. Measure the mistake, trace it backwards, take a small step downhill, and repeat until the guesses are good. If you want to go deeper, look up how different optimizers like Adam change the way that downhill step is calculated. It is a surprisingly clever twist on everything covered here.